Now, what we've been doing last several videos is modeling most of, not all of, but modeling most of a typical perfectly competitive firm. Some people like to say it's purely competitive, but I use the terms interchangeably. Anyway, what we're going to do now is something we've got a glimpse of before, and something you've seen a lot of in introductory microeconomics, and that's an imperfectly competitive firm. Now, an imperfectly competitive firm, of course, is characterized by a downward sloping demand curve. So let's do a couple of those examples. Now, we're going to complicate it in that sense. But I'm also going to, we're not going to embed the average variable cost curve into this model. We'll do that in later videos. So I'm going to complicate it in the sense that we're going to have a downward sloping demand curve, which of course means downward sloping marginal revenue curve. But I'm going to make it simpler because we're not going to worry about graphing and modeling the average variable cost curve, just the marginal cost curve. So let's see. Let's start off with a total cost function that is q cubed minus 3q squared plus q plus 7. And let's have, excuse me, let me correct that. Let's have an inverse demand function p of q equal to 16 minus q. Okay. Now, you'll see we don't have revenue here. Before we had revenue, it was just a coefficient times Q. Now we have price in the form of inverse demand. So let's go ahead and graph what that looks like real quick. Okay, so when Q is 0, price is 16. And when price is 0, Q is 16. So this is our demand curve. Okay, remember demand was constant for a purely competitive firm. Go back and watch those videos and you'll see what I'm saying. Okay, so now we have demand, but we don't have marginal revenue because marginal revenue is no longer equal to demand. It's a separate curve. How do we find marginal revenue? Well, first we need total revenue. We've got price. If we multiply this by Q, we get total revenue. So total revenue function will equal Q times P of Q. Remember, this isn't P times Q, that's P of Q. That's price as a function of Q. So this is Q times P of Q, which equals 16Q minus Q squared. Okay. Now that's total revenue. So what is marginal revenue? Well, it's the derivative of that function, which is 16 minus 2Q. So let's graph marginal revenue. When Q is 0, marginal revenue is 16, has the same vertical intercept as demand. When marginal revenue is 0, however, Q equals 8. And this makes sense because we know marginal revenue is twice as steep as demand. So that's our marginal revenue curve. Okay, now we have to find our profit maximizing output level, and we're going to do that by graphing marginal cost, which is the derivative of the total cost function. So marginal cost, C of Q, equals 3Q squared minus 6Q plus 1. And we are going to set that equal to marginal revenue. So that is 3Q squared minus 6Q plus 1 equals 16 minus 2Q. Now we get 3Q squared minus 4Q minus 15 equals 0. Breaking out the quadratic formula and solving for Q, we get Q equals, now we're just going to take the positive value of Q here. We get Q equals 4 plus or minus the square root of 16 minus 4 times 3 times negative 15, all divided by 6. What do we get on our calculator? We get 4 plus the square root of 16 minus 4 times 3 times negative 15. That is 18 divided by 6 equals 3. So Q equals 3. So right here at a value of 3 is going to be our profit maximizing output level. Marginal cost has an intercept of 1. We'll say 1 is right here. I know it's out of scale, but our graphs always are. That's not the point. But anyway, so our marginal cost function is going to look like this. Okay? Now, so we've got our graph. Here's the thing though. First, what price is being charged, and then second, can we go, given that price, can we calculate our profit? Well, if we remember, it's always the case that a firm will charge the marginal benefit of the good. Well, if we remember way back from introductory microeconomics, demand is equivalent to marginal benefit. Therefore, at a profit maximizing output level of 3, this firm will charge this much, okay, for this product. How do we find how this much is? How much this much is? Well, we take that 3 and we plug it back into the demand function. Why? Because that's where that 3 touches demand, okay? So in order to find that intersection right there, we need to take that 3 and plug it into our inverse demand function. So P of 3 equals 16 minus 3, which equals 13. So that is the price that will be charged for this product. Okay? Now, what is the profit that this firm is getting? Well, first, let's figure out cost. So that is C of 3 equals 3 cubed minus 3 times 3 squared plus 3 plus 7. And that equals 9 minus 9 times 3 is 27 plus 3 plus 7. And so that equals, wait a second. Oh, that is not 9. That is 27. Thank you for catching that. 3 times 3 is 9, times 3 is 27. That's 27 minus 27, which is 0, plus 3 plus 7. So that equals 10. So total cost is 10. What is total revenue? Well, it's price times quantity, which is 39. So revenue at 3 equals 39. Now you can calculate this as P times Q, or to be honest with you, if you took 3 and you plugged it back into this revenue function, you'll get exactly the same number. You'll get 39. Anyway, so revenue is 39, cost is 10. What is profit at a profit maximizing output level of 3? Well, it's 39 minus 10, that equals 29. Okay, now let's do one more. This time, let's say we have total cost equal to 4Q cubed minus 0.5 q squared plus 5q. Okay, notice this cost function does not have any fixed cost. Notice that. Inverse demand is going to be P of Q equals 100 minus 3Q. So let's go ahead and graph demand. When Q is 0, price is 100. When price is 0, Q is, well, it's 100 divided by 3, which is 33.3, or 33 and a third. 33 and a third, not a half. 33 and a third. So this is our demand function. Okay, that is demand. Make sure you label your graph properly. You will get points taken off if you don't label everything properly. If you don't label your axes properly, if you don't label your curves properly, you know, how do I know this is a demand curve if you didn't put a D there? I'd have no idea when I'm grading it. So you need to make sure you label all your curves and all your axes properly. Take the time to do that. So what is marginal revenue? Marginal revenue, of course, is the derivative of the total revenue function. And the total revenue function, of course, is this times Q, which is 100Q minus 3Q squared. The derivative of that is 100 minus 6Q. Okay? So when Q equals 0, marginal revenue equals 100, which should be the case. When marginal revenue is 0, Q equals 100 divided by 6, which equals 16 and 2/3, which again is 1/2 of 33 and a third. So our marginal revenue function looks like this. Okay, now let's go ahead and graph marginal cost, a derivative of the total cost function. That equals 12Q squared minus Q plus 5. Okay, it has a vertical intercept of 5. Okay, and where does it cross the marginal revenue function? Well, that is our profit maximizing output level. So we're going to set this equal to this. Okay, in other words, marginal cost equal to marginal revenue. So this gives us 12Q squared minus Q plus 5 equals 100 minus 6Q. Rearranging and simplifying, we get 12Q squared plus 5Q minus 95 equals 0. So, breaking our quadratic formula, we get Q equal to -5 plus or minus the square root of 25 minus 4 times 12 times -95, all divided by 24. Now, breaking out our calculator, we get -5 plus square root of 25 minus 4 times 12 times -95 equals 62.7 divided by 24 equals 2.61. So somewhere here at 2.61 is where marginal cost is going to cross marginal revenue. Okay. Now, how do we find the price level? We take this 2.61, we plug it back into inverse demand, and we get our price. So P of 2.61 equals 100 minus 3 times 2.61. And that equals 100 minus 3 times 2.61 equals 92.17. Okay, so this, at that output level, the price of the product is 92.17. So what is total revenue? In other words, what is R at 2.61? It is 92.17 times 2.61, which equals 240.56. And then what else we need? We got revenue. We need cost. Okay, we need total cost, right, in order to calculate profit. So C of 2.61 equals 4 times 2.61 cubed minus 0.5 times 2.61 squared plus 5 times 2.61. And so total cost equals 4 times 2.61 cubed minus 0.5 times 2.61 squared plus 5 times 2.61 equals 80.76. So then profit at 2.61 equals 240.56 minus 80.76. So that's 240.56 minus 80.76, which is 159.79. Okay. So what we've done is in one way, we've simplified things because we're not including an average variable cost function right now, but we will in subsequent videos. That said, but we've complicated things because now demand and marginal revenue are both downward sloping. But again, essentially the procedures are exactly the same as they were for perfectly competitive firms. Exactly the same, no different. The graph just looks a little bit different is all. Again, if you want to practice more of these, we just did 2 examples. If you want to practice more of these, do this. This vertical intercept right here, change it. That's that number there. Increase it. Increase it to 125 and then redo everything. Okay? Then you can increase this to 125 and maybe lower that to -2 or increase it to -4 in absolute value, increase it in absolute value -4, and then rerun it. You know, you can change this in many different ways and on your own, and just in order to get more examples out of it if you want to feel more comfortable